Hi, this is Terry VanNoy, and you are in my online classroom called Math Class with Terry V. Thanks for visiting and watching these videos. This is the start of a video series, and students, if you want to know how to become one of my students live as we work together, I work with people from all over the US, Canada, overseas, students from upper elementary age through middle school, high school, and college. Give me a call or go to my website listed up above there. Alright, let's get started. Now in this video series we're going to focus on the unit circle. Okay, first I'll describe what that means. We'll go over the basics of that, and then how it relates to the trig functions of sine, cosine, tangent, and some of the others. We'll talk about how you convert angles from radians to degrees. We'll look at the common trig values at certain angle values as we rotate around the unit circle, and then how to solve trig equations using the unit circle. So these are all related videos, and as always, look for the title How to Understand or Use the Unit Circle, and we'll go into all those aspects. Alright, let's get started with the basics of the unit circle. So here's what we mean by the unit circle. Obviously we're going to start with 1 unit of length. We're going to make that unit the radius of a circle, so we have a unit circle, and we are going to be looking at different angles as we rotate this other ray around the circle. Every time we rotate this ray around the circle, we have an angle here, and most of the time it's going to be called theta in the problem sets I'm going to show you. So sometimes it's going to be a small angle, other times it's going to open up fairly wide, sometimes it's going to spin completely around, and even go in a negative direction. So we're going to talk about positive angles, negative angles, and how they relate to the unit circle. So in this video we're going to focus a lot on this diagram, and it's pretty complicated looking at first, but I want to kind of break it down and look at the basics of this, and this is called points of special interest on the unit circle. Alright, so let's kind of scroll this up a little bit and let's look at some of the basics here. We're going to start in the middle of the circle, and we're going to draw a radius that is obviously 1 unit from center of the circle out to the edge of the circle. And that's true all the way around this circle, so that's why it's called a unit circle. Notice that we have an x-axis going this way and a y-axis going this way. So we're going to be looking at the coordinates around the circle as we open that angle up in a positive and a negative direction. Now over here on the right hand side, the coordinates of that point is 1, 0. Okay? Notice how it's at 0 degrees. Now as we open this up, now we have a 90-degree angle. Okay? And notice how the ordered pair is 0, 1. So we are straight up. Okay? We have a 90-degree angle from there to there. Now if we flatten it all the way out, of course, now we have 180 degrees, which is negative 1, 0. And 3/4 of the way around we have 270 degrees and 0, negative 1. And if we do one complete rotation, we are now back to 1, 0. So that 0 degrees is actually 360 degrees at the same time. And we'll talk a little bit more about that, how certain angles have lots of different names, positive and negative. So you notice how I used the designation of degrees. So one way to measure angles is through degrees, as you can see by these numbers here on the smaller area of the circle all the way around. Okay, from 0 all the way around to 360. Those are degrees. I'm sure you've seen how the same degree angle in measures is in a pi unit here. These pi units here, just another way to measure an angle, is called a radian. Alright, now let's take a little time out and talk about what a radian is. Now to talk about a radian, we have to imagine that we are on this point of the circle, and we actually want to travel all the way around that circle. Okay? Now we know that the radius of that circle is 1 unit. So the question is, how far do you travel if you go all the way around? So if you open up that degree, all the way around 360 degrees. But we want to rename these angles instead of in degrees. in how much of the circumference you're traveling. So how far around you're spinning in the circle. Well, you know that the formula of the circumference of a circle is pi times the diameter, which is 2r. Okay, sometimes textbooks will say 2 pi r. It doesn't matter the order because we're just multiplying. Now, we know that the radius, though, is 1, right? So, in this case, all we do is substitute 1 in place of the radius, and that gives us the complete distance all the way around the circle is 2 pi. So what we've done is we've taken the fact that if we spin completely around that circle, that is going to be 2 pi radians. Okay, that's a complete 360-degree spin around that circle. Okay, now we're going to convert everything now into radians, back and forth from radians to degrees. So keep that in mind, that all the way around the circle is based on 2 pi. Okay, that's a basic unit you'll have to memorize. So knowing that, if we start at 0 degrees and we only go halfway around, that's going to be 180 degrees, yes, but it also is halfway around 2 pi. So 1/2 of spin around the circle is going to be pi radians, okay? So that's what we've got right there. All right, halfway around is pi. So completely around is 2 pi. All right, now again, it could be called 360 degrees, but we're going to call it 2 pi if we look at it in terms of radians. So half a spin is pi, one complete spin is 2 pi. Now, based on that a 90-degree angle is going to be pi over 2 because you've gone halfway up, not all the way flat. And then if we go pi over 2, pi, this must be 3 pi over 2. Okay, you can think of it as 1/2 pi, but we keep it in fraction form, not mixed number form. So 3/4 the way around is 270 degrees, but also it's 3 pi over 2. And the complete spin around again is 2 pi. All right, so let's kind of analyze these radian measures. Let's take the knowledge that going from 0 all the way flat is 180 degrees or 1 pi. So we're going to take half of the spin around, so 1 pi unit. Let's break it into 3 parts. So we have pi over 3, which is 60 degrees, right there at that point. And we have 2/3 pi, which is 120 degrees at that point. So we've gone from 0 to pi in 3 parts. We've divided that distance into 3 equal parts. So it's 0 pi, 1/3 pi, 2/3 pi, 1 complete pi. Same down below. We can go 1/3 more of a pi, which is 4/3 pi down here, 240 degrees. And we can go right down here to 5/3 pi, which is 300 degrees. And then completely all the way around would be 2 pi. So once again, for the 1/3 of radians, we have 1/3 pi, or pi over 3, 2/3 pi, and 1 whole pi, which is always 180 degrees. And then we have another 1/3 of a pi, another 1/3 of a pi, and then complete spin there. Okay? Those are the thirds. Look at the fourths. Pi over 4, or 1/4 pi, is 45 degrees. Notice how we're going halfway up to 90 degrees. So pi over 4, pi over 2, which is 90 degrees, and then we go halfway here, which would be 3/4 pi, 135 degrees, right? And then we have our 1 pi, or 180 degrees. So 1/4 pi, 2/4 pi, 3/4 pi. Notice how we can simplify there. Then we go down here to 5/4 pi, which is 225 degrees. We're going 45 degrees every time. Then 270 is 3 pi over 2. And then, of course, we have 7/4 pi, which is 315 degrees. And then all the way around. Okay? So we've got 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, 270 degrees, 315 degrees, and then all the way around. So the point here is being able to convert from degrees to radians, and think of radians as parts of pi, and pi is halfway across. And now finally let's look at the 1/6 of a pi. So if we go 1/6 of the way across to the flat pi, or 180 degrees, pi over 6, which is 1/6 pi, that's 30 degrees. Okay, you're only going up about a 30-degree angle. Then if we go 2/6, that would be here. Notice how we would reduce that to pi over 3. And then we have 3/6, which is pi over 2, 90 degrees. Next, 2/3 pi. And next, 5/6 pi. Alright, so we've divided this distance from 0 to 180 degrees, or 0 to pi radians, into 6 parts. Okay, and each of those parts represents 30-degree increments. So here we go. Here's some more. Right there. Right there. Right there. Right there. Right there. And finally 2 pi all the way around. So I wanted to analyze this unit circle diagram, and we'll continue to do that in the next video, but I want you to notice how degrees and radians are related. In our next video, we're going to take a look at these circle points here. Where do we get these radicals and these fraction values for x and y based on special right triangles? Thanks for watching.